5.3, number 172. We have the definite integral from -2 to 3 of t plus 2 times t minus 3 dt. It doesn't have to use x's or t's, the whole thing's the same. We're supposed to use, hope it's obvious from the way the formulas looked before, fundamental theorem of calculus, part 2. All right. So what that means is we need to find an antiderivative of this, plug in the numbers, and subtract. So to find an antiderivative of this, there's a small problem. We have a product in here. And as I tried to stress before, we don't have a product rule for antiderivatives, right? Product rule for integrals, even though there's a product rule for derivatives. And also we don't have a quotient rule, like I said before. We'll develop more rules as we go along, but those two we don't have at the moment. So we should go ahead and multiply these two together to get a regular polynomial in here that we can apply the reverse power rule to. So that's the first thing we're going to do. We're going to rewrite this, -2 to 3, t squared, I guess if you multiply it out, you get a minus t minus 6. So t squared minus t minus 6 dt. Now we can apply the integral symbol to each of these separately. I'm going to go ahead and do that one more time for this problem, and then I'm going to probably stop writing it out so fully because it will become burdensome. So -2 to 3 t squared dt minus integral of t itself, -2 to 3, and then minus 6, which I can pull to the outside, dt, -2 to 3. Okay, the reason this is going to be burdensome this way is because if you do it this way, and you write explicitly that this has been distributed across these three, then what you'll be left with is writing the antiderivative of each of these three separately. So 1/3 t cubed, of course, we're going to raise the power by 1, multiply by reciprocal, evaluate from -2 to 3. So you write this on each one of these now. It'll just be a little bit repetitive. So t goes up to a power of 2, multiplied by the reciprocal, so you get 1/2 t squared from -2 to 3. And then minus 6t, of course, right? Again, the integral symbol with just dt or dx is just that variable from -2 to 3. Okay, so to save us from writing this with 3 and -2 in, this with 3 and -2 in, this with 3 and -2 in, I'm going to write it differently. I'm going to remove this to the outside of the hole. Well, this is a fine way to do it. It doesn't matter. You can go ahead and put 3. Actually, I will do it that way. I'll just do it that way, just to be consistent with what we have here. So we'll have 1/3 3 cubed minus 1/3 -2 cubed, right? That's this first one here. And the next one, right, same thing. Minus, gotta be a little careful here, minus 1/2 3 squared, and the minus from the fundamental theorem, 1/2 -2 squared. Another minus 6 times 3 minus 6 times -2. Okay, so there's the fundamental theorem of calculus applied to each of these three separately. Let's go ahead and close this one too while I'm at it. All right, again, antiderivative with 3 and -2 plugged in, subtracted. Minus, minus. Antiderivative with 3 and -2 plugged in, subtracted. Minus, minus. Antiderivative with 3 and -2 plugged in, subtracted. Now we just do the calculation. So this is, of course, 1/3 9 minus -8. So 1/3, we have 9 plus 8. We just think about it, right? The 1/3 could factor off. I could have left it to the outside, actually. I'm just trying to be as true to the formulas right now as possible. But certainly there's room for maneuvering in here to make the calculations a little bit more simple. So 9 minus negative 8 would be 9 plus 8. Minus, again, the 1/2 could have been left out here. I'm going to pull it out now just for ease of calculation. We'll have 9 minus 4. And then finally we have the 6 could be pulled out, and we'll have 3 minus negative 2 on the inside. Okay, just continue with the calculation. Again, a little burdensome here. 17 thirds minus 5 halves minus 30. Now we just need to get everything with the same denominator, so the denominator of 6 looks like it'll cover it. So we'd have something like, this needs a 2, so 34 sixths. This needs a 3, so 15 sixths. This needs 6, unfortunately, so negative 180 sixths. Okay? So negative 180 and negative 15 should be negative 195. Negative 195 and 34 should be negative 161. So we get negative 161 on 6. And 2 does not go into 161 because it's an odd number, and 3 does not go in because 6 plus 1 is not divisible by 3 either. So this is our final answer, negative 161 over 6.